Hello and welcome to Digital Zone channel. My name is Iris and today we will take a look how to Shrinkwrap Modifier works in Blender, what its options are and what it's used for. By the end of the video, you will know how to, for example, stick a label onto a product. In the scene, we will add two objects using the shortcut Shift-A or the Add option in the top menu. The first one will be a 3D object onto which we will sticking things. For this demonstration, I have chosen a sphere. The second object will be a 2D plane that will serve as a sticker we will attach to the other object. You can later upload an image onto the plane. For better clarity, we can switch to viewport shading and color both objects with the contrasting colors to make them easier to work with. We have the sphere in the center of the world. Let's move the plane up above the sphere and scale it down a bit. When using the Shrinkwrap modifier, it's important to place the plane roughly near the spot where you want to stick it. After it's attached, the movement options are very limited. Select the plane and switch to edit mode using the top menu or the tab key. Right-click on the plane and choose Subdivide, which will split the plane into several small squares. This step is important. As long as the plane consists of a single large square, it can be bent or deformed because bending in Blender works by moving vertices, and there are only 4 of them here. In the number of cuts field, set for example 30 cuts. The more cuts you choose, the smoother the deformation will be, but the more complex the model becomes. Once we have finished subdividing, we switch back to object mode and assign a modifier to the selected plane. The modifier tab is located in the right-hand menu under the spanner icon. Choose Add Modifier and find the Shrinkwrap. At this point, nothing interesting has happened. We know we want a plane to stick to the surface of the sphere, because, logically, there is nothing else in the scene. But Blender doesn't think that way. We need to specify the target object exactly, which we can do either using the drop-down menu or the eyedropper tool. Now, Blender knows where to stick the plane. Unfortunately, Blender can be very literal. And when we told it to stick the plane to the surface of the sphere, it did exactly what we said, literally. It attached the sticker so tightly to the sphere that the two objects overlap. Fortunately, there is an offset field which creates a gap between the plane and the target object. For us, a very small gap is enough. And that's how you can easily stick a 2D sticker onto a 3D object. But if you want to be really good at Blender, it's not enough to just blindly follow a tutorial. It's important to understand how the tools we use actually work, how to set them up, and where their limits are. So, now let's take a look at how the Shrinkwrap modifier actually works. The first thing you will probably notice is what happens when you try to move the sticker to another part of the sphere. Instead of moving as a whole, it starts to deform strangely or even disappears completely. That's because Shrinkwrap doesn't work like a magnet that attaches the sticker to the surface and lets you freely slide it around. Once you stick it, for example, to the top of the sphere, you can just easily move it down. The modifier doesn't move the sticker as a whole. It works with individual vertices, projecting them from their original position towards to the target object. There are several ways it can do this, called wrap methods. In general, it always looks for the nearest point on the target object that the sticker can attach to. That's why it's really important where we place the plane before using the modifier. Before we explain how to use the different wrap methods, I need to introduce you to another concept: normals. Every triangle or face has a little arrow sticking out from its surface. This arrow isn't usually visible, but it's there. It shows which side of the face is the outside. Blender uses it to know what is the outside and what is the inside of an object. Normals affect lighting, shadows, rendering, and also how shrink wrap projects. And normals are especially important for some wrap methods. The first wrap method is nearest surface point. It works by moving every point of our sticker, not just the vertices, but also the point in between, to the nearest spot on the surface of target object. You can think of it like a small magnetic force that pulls the sticker towards the 3D object along the shortest path. This method is ideal where the surface is smooth and obstacle-free, like a sphere or rectangle. If the target object is more complex, for example a sphere on the rectangle, some points may deform and the mesh won't match exactly. The nearest point the sticker can attach to might not be where we want it, and unfortunately the sticker doesn't care about keeping its shape. It prioritizes sticking to the nearest point whether it deforms or not. This is important to keep in mind before using this method. The next wrap method is called project. Here the vertices of our sticker are projected in chosen direction. It's more suited for directional projection than for sticking because some vertices might miss the target, which can look strange. Imagine each vertex launching in a certain direction. This is called a raycast, either along an XYZ axis or along the normals similar to a ray of light. If the ray hits the surface of the target object, the point sticks and stays here. But if the ray hits nothing, the point remains in its original position. This method is by far the most complex in the entire Shrinkwrap modifier and has several special settings that other methods don't have. Back to the wrap methods. The next one is nearest vertex. This method sticks the sticker to the nearest vertices of the target object. Each point moves exactly to the nearest existing vertex of the target mesh. If the target object has clearly and precisely placed vertices, we can easily copy them this way. The problem arises with a smoother object because the result can look rough. The next wrap method is target normal project. This is somewhat more advanced method that uses the normals of the target object. Blender takes the direction of the normals on the target object and casts the points of the sticker along them. Imagine each point falling directly along the arrow from the surface. Thanks to this, the mesh exactly wraps the surface of the target object and follows its shape according to the normals. Besides the wrap method, we can also set a snap mode, which affects how the vertices attach to the target object. It determines exactly where the vertices stop when cast from their original position towards the target, whether on the surface, beneath it, or with a gap between the sticker and the object. The last option we haven't covered are located up here under these icons. The first one is Uncage. When enabled, Shrink Wrap takes into account changes already applied by other modifiers, such as subdivision, mirror, or simple deform. If it's off, Shrink Wrap uses the original geometry, as if no modifiers were applied before it. It also affects how we see the sticker model in edit mode. Edit mode. When this option is enabled, in edit mode we can see not only the original position of the sticker before activating the shrink wrap modifier, but also the final state after the sticker is attached. If we disable it, we only see the original position. Real time. Basically, does the same thing but applies to the viewport. It affects how we see the stickers in the viewport. Render. The last icon determines how and whether the stickers will be rendered. And that, ladies and gentlemen, was the Shrinkwrap Modifier. If you found this tutorial helpful and learned something new, feel free to support me with a like, subscription or comment. If you would like to support me financially, you can buy me a coffee on Buy Me a Coffee page, link in the description below. It's all for today and I will see you next time in another tutorial.